Okay, let's get started. So we have two balls. Just draw it. They're rolling towards each other. Whee! Right? So the red one's on the right. Okay. Right? And then they collide each other. And then whenever they collide, the red one still keeps moving forward. So since the red one still keeps moving forward, it's like this. And the green one is going to move that way because they collide. And the green one obviously bounces back, but the red one keeps moving forward. So we're just going to draw this right here. We're going to label everything that we're given. So we're given that the red ball has a mass of 0.5 kilograms, and then velocity has a speed, is going to be a speed of 4 meters per second. Ball. And then the green ball has a mass of 0.2 kilograms, and then a velocity of 2 meters per second. So question, now that we labeled everything that we have, we also know, oh, by the way, that the red ball is going to have a final velocity of 2 meters per second. We need to, since this is velocity, we know that velocity is a vector, so therefore it has a direction. So which one of these directions is going to be in the negative direction? Left or right? Left. Okay, so it's going to be in the left direction. So since it's in the left direction, then my green ball will be going into the negative direction. Yeah, negative direction. So since my green ball is going into the negative direction, okay, so this is my diagram, and I know that my green ball is going into the negative direction. So because I know that, I can then plug in my numbers into my formula as a positive or negative. So we're going to start with our equation. We know that these objects don't stick together, so we're just going to use mv plus mv equals mv plus mv. And then we know it's going to be mv, a is going to be red, b is going to be green. Okay, so mv a, b, and b. Okay, so then mass of A is 0.5 kilograms. Velocity is going to be 4 meters per second. So I'm just plugging in all the information that I'm given. And I'll zoom in a little bit. Okay, and then mass of ball B is going to be 0.2 kilograms times negative 2 meters per second. And then mass of A is 0.5 kilograms. Velocity of A. And the final velocity, as we said before, it's going to be 2 meters per second. And since it's going forward, that means it's still going in the direction that it originally was going in. So it's going to be positive 2 plus the mass of ball B, which is going to be 0.2 kilograms, times the velocity of B. So we are trying to find the velocity of B. So all I did was just plug in everything. Now I'm just going to algebraically solve for it. So whenever I algebraically solve for it, what do I get? So take some time to solve for that. Okay, so whenever you algebraically solve for this, it's going to be BB equals 3. So just make sure that you put this in the calculator to make sure that you're getting this answer, because whenever we were doing it in the other classes, a lot of people were just making simple mistakes like adding instead of multiplying, or just reading the numbers wrong, or the biggest mistake was not putting in the negative sign. So we know that velocity of the ball will be 3 meters in the 3 meters per second in the positive direction. Okay, so another question I had was, why is A going in the same direction that it was, but B changed direction? Right, so the reason being is because A had actually had a larger mass and a larger velocity. So because of those two variables, especially because of the velocity, it had a larger momentum. So because it had a larger momentum, that means it's going to tend to move in the direction that it was going in. It's probably going to move a little bit slower, like you see right now. It's from 4 meters per second to 2 meters per second, but it's still going to be moving in that direction. Whereas B, it's going to be 3 meters per second, so it's going to be moving in the positive direction. Let's go on to letter B. So going on to letter B, we're going to find what is the total kinetic energy before collision. So remember, total kinetic energy is K total is going to be equal to Ka plus Kb. So that is going to be 1/2 mv squared plus 1/2 mv squared. What is one thing that I can factor out from these two? What is one thing that I can factor out? Maybe not mass, because they're two different masses. The 1/2. So I can factor out the 1/2. I can't factor out mass or velocity because they're all different. So mass velocity plus mass velocity. Okay. So let me know if I'm going too fast, but I'm speed running it a little bit because we lost some time. So 1/2 of mass of A, which is going to be 0.5 kg times 4 squared plus mass of 0.2. And this is before collision, so we're going to put -2 squared. And then your velocity should be, I believe, 4.4. Okay? 4.4 joules. Okay? So K total is going to be equal to, so this is going to be after collision, so Ka plus Kb, same thing. And then we're going to do 1/2 of 0.5 times velocities after collision, so that's 2 squared, plus 0.2 times 3, which is what we solved for in the last equation. Okay, so for letter A, we've solved for B. And then I should get, I believe, 1.7. I don't remember. If I'm wrong, just let me know. But it's in the ballpark. But the whole point of this is, if it's wrong, just correct it on your paper. The whole point of this is to determine, is this collision elastic? So what is one thing that defines an what are two things that define an elastic collision? Momentum is conserved, and then kinetic energy is conserved as well. So we know that in an elastic collision, P is conserved, and so is K. So Ke is conserved. So that means K before has to be equal to K after. Is that true here? No, that's not true. We know that K before, okay, K before is going to be 4.4 joules, and then K after is going to be 1.7 joules. So we know that kinetic energy is lost. So since that kinetic energy is lost, what actually happened to it? What was one thing that kinetic energy could have turned into? Thermal friction. What else? Maybe not potential energy, because it's all on one flat surface. Does it make a sound? Does it make a sound? Yeah. Yeah, it does make a sound. Okay, so kinetic energy can be turned into friction or sound. So we can write, yeah, So like whenever sound energy. Yeah. So like whenever balls like they collide, they're like this, right? So like all that kinetic energy gets turned into sound energy. Okay. So those are some reasons why kinetic energy wouldn't exactly be conserved. So let's write that out. So this would be practice on your FRQ. So this collision is going to be inelastic because Ke is not conserved. The kinetic energy before is greater than kinetic energy after Ke turned into heat or sound. So that's one way to determine it.